So these are homogeneous differential equations. So to be able to separate these types of equations, we need to kind of do some manipulation of these equations. So typically they're this form, x, they have this f over x over y. They're this type here. They're hard to separate out. Okay, and so what we can do is we can actually rearrange this equation by using this little trick. We can just say that y over x is equal to v. And if we do that, then we can just rearrange this to y equals vx. And then we can generate the derivatives here using the chain rule. Okay? The product rule. And then by doing this, we can rearrange our expression for dv over dx. And we end up with something like this. And then we can rearrange it into this form here. So that's one way to do it. And basically this form, if you look at it, we can separate the v from the v's and the x's with the x's, and we can integrate this in terms of v and x instead of y and x. Okay, so that's the idea. We're just using a substitution to be able to rearrange them to integrate in terms of some other variables. The other way to do this is we can substitute y equals vx, and then we can replace the dy in the expression with this form here when we do the product rule for that. Okay, so it's v x dv plus v dx. Okay, so we're going to use that second strategy here, and we're going to just substitute. Okay, so we're going to replace the y here. Okay, so we're going to end up with x minus, and y is going to be replaced by vx. Okay, and this is going to be, the dy is going to be replaced by x dv plus v dx. Okay. Make that a little bit nicer. X dv plus v dx all over dx. Okay, and then we're going to just try to rearrange this so that the parts can be separated out. Okay, the x parts from the v parts. Okay, so we end up with, this ends up being x dv plus v dx is equal to, this becomes 1 minus v. Okay, 1, that simplifies to 1 minus v, and then I'm going to move the dx to this side. Okay, so then I want to group my dx's together so I can put it in a separable form. So I'll have x dv on this side. I'm going to have minus v dx plus dx minus v dx. So I have minus 2 v dx's. Okay, so I end up with x dv on this side is equal to, looks like 1 minus 2v, and then we have dx on this side. Now we can separate and integrate. We get v dv over 1 minus 2v is equal to dx over x. Separate, integrate both sides now. We end up with log 1 minus 2v is equal to log x plus c. Okay, and we can get rid of this brackets here. We can substitute back in our v is equal to y over x. Okay, so log 1 minus 2y over x is equal to, and we're going to combine this c in here. We're going to make that c2. Okay, we'll make this into c2 is equal to, c is equal to log c2. Okay, and then we use the log properties to put those together, and then we can solve for the y here. So we get 1 minus 2y over x is equal to c2x, and then let's move those over. Okay, so it's going to be negative 2y over x is equal to c2x minus 1, and then y is equal to negative x over 2 c2x minus 1. So there's the solution to this differential equation of x minus y over x. Okay, so we can generate terms with y over x, or we can substitute y equals vx. This typically is easier, and then we can use either formula 1 or formula 2. We can put it into this form here and separate, or we can use dy, replace the dy with this expression, the product rule expression that we generate. Okay, so let's try this one. Let's in this one here, I'm just going to replace again the dy with x dv plus v dx. That's going to be over dx, and then I'm going to replace the y with a vx expression. Okay, so we can simplify things here. This side simplifies to, it's going to be 1 plus 2v all over 3, and we'll separate these parts here. So that's we're going to multiply that by dx, and this is going to be x dv plus v dx. Okay, so we want to group the v terms with the dx on this side. So we end up with x dv on this side, and then actually let's do this first. Let's go 3x. We're going to multiply both sides by 3, so we end up with negative 3v dx. Okay, and then that's going to be plus 1 dx plus 2v dx when I multiply into those brackets. Okay, so then I can combine the terms here, so I end up with 3x dv is equal to, it's going to be 1 minus v. So we have 2v's here, we're going to minus 3v, so we're going to end up with minus v. Factor out my dx. Now I can separate and integrate. dv over 1 minus v is equal to dx over 3, actually I'm going to leave the 3 over here. Okay, so separate, integrate, I get log 1 minus v is equal to log of x plus c. Again, we'll put the plus c in there, so this ends up being log of 1 minus v cubed is equal to log, and I'm gonna call that k this time, kx. The plus c ends up inside as a kx. Okay, and then I end up with 1 minus v, and I'm going to replace the v with a y over x cubed is equal to kx. Okay, this doesn't give us any initial point that I can solve for k. I could try to solve for y. I think this is good enough though. I think we can just leave it in that form. If you want, we can solve for y by just undoing those algebraic parts. So, we can substitute Vx and plug into formula 1, or we can use the formula 2, formula 2 or formula 1 to be able to do substitution, and then we get a form that we can rearrange and be able to separate in terms of v and x instead of y and x. Okay, so here's one more here. Okay, this is giving us initial condition, so we can actually solve for the k value. So we're going to substitute our y equals vx again. Okay, and then our dy, we're going to substitute with v dx plus x dv. Okay, so then we end up with 2x, and then there's our vx. Our dy is going to be replaced by v dx plus x dv all over dx. Okay, so then that's equal to x squared plus 2, and this is vx squared like that. Okay, so then I want to separate these parts out, so I'm going to end up with 2vx squared times v dx plus x dv I'm going to multiply the dx onto the other side, so I end up with x squared dx, and this is going to be 2, plus 2v squared x squared dx. So I'll multiply this out again and then group my dx terms. So 2v squared x squared dx plus 2v x cubed dv is equal to x squared dx plus 2v squared x squared dx. And we can cancel out these two terms, and then now we have a separable differential equation here. I'll just write it in one more line. Okay, so before I do that, I'm gonna actually put the x over there. So 2v dv is equal to dx over x when we cancel out the powers here. Separate, integrate, end up with v squared is equal to log x plus c. I'm gonna substitute back here, so y over x squared is equal to log of kx. Plugging in my x and y, so x is 1, y is 0. So I'm going to end up with 0 on this side. That's equal to log of k times x is 1. So log k, so k is going to be equal to log of 1 is equal to 0, so k is equal to 1. Okay, so then solving the rest of this, I'm going to rewrite this as y squared over x squared is equal to log x, and so we end up with y squared equals x squared log x. Okay, so there is a solution to this differential equation. Okay, so again, we're using a trick here to, not a trick, but this kind of substitution here to kind of generate a form that is separable, not in terms of x and y, but in terms of v and x.